The Dassault Rafale, literally meaning gust of wind, and burst of fire in a more military sense, is a French twin-engine, canard delta-wing, multi-role fighter aircraft designed and built by Dassault Aviation. Equipped with a wide range of weapons, the Rafale is intended to perform air supremacy, interdiction, aerial reconnaissance, ground support, in-depth strike, anti-ship strike and nuclear deterrence missions. The Rafale is referred to as an omnirole aircraft by Dassault. In the late 1970s, the French Air Force and French Navy were seeking to replace and consolidate their current fleets of aircraft. In order to reduce development costs and boost prospective sales, France entered into an arrangement with the UK, Germany, Italy, and Spain to produce an agile multi-purpose future European fighter aircraft, what would become the Eurofighter Typhoon. Subsequent disagreements over workshare and differing requirements led to France's pursuit of its own development program. Dassault built a technology demonstrator which first flew in July 1986 as part of an 8-year flight test program, paving the way for the go-ahead of the project. The Rafale is distinct from other European fighters of its era, in that it is almost entirely built by one country, involving most of France's major defense contractors, such as Dassault, Thales, and Safran. Many of the aircraft's avionics and features, such as direct voice input, the RBE-2AA active electronically scanned array, AESA, radar and the Optronique secteur frontal infrared search and track, IRST, sensor, were domestically developed and produced for the Rafale program. Originally scheduled to enter service in 1996, the Rafale suffered significant delays due to post-Cold War budget cuts and changes in priorities. The aircraft is available in 3 main variants: Rafale C single-seat land-based version, Rafale B twin-seat land-based version, and Rafale M single-seat carrier-based version. Introduced in 2001, the Rafale is being produced for both the French Air Force and for carrier-based operations in the French Navy. The Rafale has been marketed for export to several countries, and was selected for purchase by the Egyptian Air Force, the Indian Air Force, the Qatar Air Force, the Hellenic Air Force, the Croatian Air Force and the United Arab Emirates Air Force. The Rafale has been used in combat over Afghanistan, Libya, Mali, Iraq, and Syria. In the mid-1970s, both the French Air Force and Navy had requirements for a new generation of fighters, to replace those in or about to enter service. Because their requirements were similar, and to reduce cost, both departments issued a common request for proposal. In 1975, the French Ministry of Aviation initiated studies for a new aircraft to complement the upcoming, and smaller Dassault Mirage 2000, with each aircraft optimized for differing roles. In 1979, the French company Dassault joined the European Collaborative Fighter Project, which was renamed the European Combat Aircraft, ECA. The French company contributed the aerodynamic layout of a prospective twin-engine, single-seat fighter. However, the project collapsed in 1981 due to differing operational requirements of each partner country. In 1983, the Future European Fighter Aircraft (FEFA) program was initiated, bringing together Italy, Spain, West Germany, France and the United Kingdom to jointly develop a new fighter, although the latter 3 had their own aircraft developments. A number of factors led to the eventual split between France and the other 4 countries. Around 1984, France reiterated its requirement for a carrier-capable version and demanded a leading role. It also insisted on a swing-role fighter that was lighter than the design favored by the other 4 nations. West Germany, the UK and Italy opted out, and established a new European Fighter Aircraft (EFA) program. In turn, on 2 August 1985, West Germany, the UK and Italy agreed to go ahead with the EFA, and confirmed that France, along with Spain, had chosen not to proceed as a member of the project. Despite pressure from France, Spain rejoined the Eurofighter project in early September 1985. The 4-nation project eventually resulted in the development of the Eurofighter Typhoon. The Rafale was developed as a modern jet fighter with a very high level of agility. Dassault chose to combine a delta wing with active close-coupled canard to maximize maneuverability. The aircraft is capable of withstanding from 3.6 G to 9 G. The Rafale is an aerodynamically unstable aircraft and uses digital fly-by-wire flight controls to artificially enforce and maintain stability. The aircraft's canards also act to reduce the minimum landing speed to 115 knots, while in flight, airspeeds as low as 15 knots have been observed during training missions. According to simulations by Dassault, the Rafale has sufficient low-speed performance to operate from Stober-configured aircraft carriers, and can take off using a ski jump with no modifications. The Rafale M features a greatly reinforced undercarriage to cope with the additional stresses of naval landings, an arrestor hook, and jump strut nose wheel, which only extends during short takeoffs, including catapult launches. It also features a built-in ladder, carrier-based microwave landing system, and a new fin-tip telemer system for sensing the inertial navigation system to external equipment. Altogether, the naval modifications of the Rafale M increase its weight by 500 kilograms compared to other variants. The Rafale M retains about 95% commonality with Air Force variants, including, although unusual for carrier-based aircraft, being unable to fold its multi-spar wings to reduce storage space. The size constraints were offset by the introduction of Charles de Gaulle, France's first nuclear-powered carrier, which was considerably larger than previous carriers, Foch and Clemenceau. Although not a full-aspect stealth aircraft, the cost of which was viewed as unacceptably excessive, the Rafale was designed for reduced radar cross-section, RCS, and infrared signature. In order to reduce the RCS, changes from the initial technology demonstrator include a reduction in the size of the tail fin, fuselage reshaping, repositioning of the engine air inlets underneath the aircraft's wing, and the extensive use of composite materials and serrated patterns for the construction of the trailing edges of the wings and canards. 70% of the Rafale's surface area is composite. Many of the features designed to reduce the Rafale's visibility to threats remain classified. The Rafale's glass cockpit was designed around the principle of data fusion as central computer selects and prioritizes information to display to pilots for simpler command and control. The primary flight controls are arranged in a hands-on throttle and stick, HOTAS-compatible configuration, with a right-handed side stick controller and a left-handed throttle. The seat is inclined rearwards at an angle of 29 degrees to improve G-force tolerance during maneuvering, and to provide a less restricted external pilot view. An intelligent flight suit worn by the pilot is automatically controlled by the aircraft to counteract in response to calculated G-forces. Great emphasis has been placed on pilot workload minimization across all operations. Among the features of the highly digitized cockpit is an integrated direct voice input (DVI) system, allowing a range of aircraft functions to be controlled by spoken voice commands, simplifying the pilot's access to many of the controls. Developed by Krause, the DVI is capable of managing radio communications and countermeasures systems, the selection of armament and radar modes, and controlling navigational functions. For safety reasons, DVI is deliberately not employed for safety-critical elements of the aircraft's operation, such as the final release of weapons. For displaying information gathered from a range of sensors across the aircraft, the cockpit features a wide-angle holographic head-up display (HUD) system, two head-down flat-panel color multifunction displays (MFDs), as well as a central collimated display. These displays have been strategically placed to minimize pilot distraction from the external environment. Some displays feature a touch interface for ease of human-computer interaction (HCI). A head-mounted display (HMD) remains to be integrated to take full advantage of its Mica missiles. The cockpit is fully compatible with night vision goggles, NVG. In the area of life support, the Rafale is fitted with a Martin Baker Mark 16 F00 ejection seat, capable of operation at 0 speed and 0 altitude. An onboard oxygen generating system, developed by Air Liquide, eliminates the need to carry bulky oxygen canisters. The Rafale's flight computer has been programmed to counteract pilot disorientation, and to employ automatic recovery of the aircraft during negative flight conditions. The autopilot and auto-throttle controls are also integrated, and are activated by switches located on the primary flight controls.